Okay, so today we're going over the second part for tests for parallelograms. So we're still looking at parallelograms and their sides. So, we're quiet now, please. On the coordinate plane, to find out if a quadrilateral is a parallelogram, you can use the distance formula, the slope formula, or the midpoint formula. Today we're going to use distance and slope. Okay? So by using the distance formula, what we want to do is find the length of our sides in our quadrilateral. We want to find the length of the sides of our quadrilateral, and we want to compare the sides opposite each other. If they're equal, then it is a parallelogram. If they're not, then it's not a parallelogram. With our slope, we're going to do the same thing. We're going to find the slope of each side, okay? And if our opposite side slopes are the same, then it is a parallelogram, okay? So in our example, we have our vertices at these coordinate points right here. The first method we're going to go through today is the slope formula. Okay, so we're going to use this formula right here. And we're going to find the slope of each side of our quadrilateral. So from A to D, that's this side, B to C, A to B, and C to D. Okay, so all four sides there. So I'm using points A and points D and plugging them into this formula here. So our slope for AD, we're going to take y sub 2, which is 0, minus y sub 1, again going back to A, that's 3, over x sub 2 is negative 3, minus x sub 1 is negative 2. Okay, so I have negative 3 over negative 1. Okay, that's just 3. Okay, so I'm just finding the slope of each of these lines. Now, since I do have the graph, I can do this a different way instead of plugging my values in. So if I'm going to look at BC now, okay, that's this line right here, right? To find your slope, you need to do rise over run. So if I go from point C to point B here, I need to go up or down first. So I'm going to go 1, 2, 3 up, and then 1 to the right. Okay, so my slope, I went up 3 and 1 to the right. Okay, so my slope is 3. So we're on the right track for this being a parallelogram. So my opposite side slopes of these two sides are the same, but I need to make sure my other two slopes are the same. Okay, so I'm going to find the slope of AB. Again, you can either use the formula or you can look at your picture. So if I go from point B to point A here, my rise is 1. So I go up 1. And then I go over 1, 2, 3, 4, 5. But I'm going left, so that means it's going to be negative. Do you know how I got negative 1/5? I'm going from B to A. Your slope is your rise over your run. I need to go up 1, that's where I got the 1 from. And then my run is from left to right. Since I'm going left, it's negative. And I went left 5 spaces, so I have negative 5. Okay, next I need the slope of CD. Okay, again, I rise 1. And I go left 1, 2, 3, 4, 5. Okay, so Now I have these two sides. They have the same slope. They're opposites. And these two are opposite, and they have the same slope. Okay? So since opposite sides have the same slope, then I can say segment AB is parallel to CD, and AD is parallel to BC. Okay? Since they have the same slope, they have to be parallel. Therefore, ABCD is a parallelogram. Okay? So that's how you would use the slope formula to see if your figure is a parallelogram. Opposite sides have the same slope. Questions on that one? All right, on the back, we're going to use the distance formula. Okay, so when using the distance formula, again, we want to do opposite sides, okay, in our quadrilateral, and we want to see if they are the same. So for AB, I'm using these 2 points here, okay, so I'm using -2, 3, and 3, 2. Okay, I'm just going to write those next to that segment just so I know those are the ones I'm using. Now, if the distance formula still kind of makes you a little bit confused, you can label your points x sub 1 and y sub 1, and x sub 2 and y sub 2. Okay, now with that, I can plug those values into this formula here. Okay, so we have the square root. We'll say x sub 2 is 3 minus x sub 1 is -2, and that's squared, plus y sub 2 is 2 minus y sub 1 is 3, and that is squared. Okay, so I have 3 minus -2, that's 5 squared, plus 2 minus 3 is -1 squared. Okay, so I want to square both of those terms, so I have 5 squared is 25, plus -1 squared is 1. And I get the square root of 26. And I'm just going to leave it like that. I'm not going to plug it into the calculator and get a decimal, because all I'm doing is seeing if my two sides are congruent. So if I get down to both of them are the square root of 26, then they're congruent and you don't have to go any further. Okay, so next one I'm going to do is side CD, since these ones are opposite sides in my quadrilateral. So again, I'm going to write down my 2 coordinate points. So I have 2, -1, and -3, 0. And I want to label those. So this first one is x sub 1, y sub 1, and x sub 2, y sub 2. Okay, from here, I can plug in those points. So we'll take x sub 2 is -3. Minus x sub 1 is 2, that's squared, plus y sub 2 is 0, minus y sub 1 is -1, and that is squared. So again, I'm just plugging in my values into my formula up here. Okay, so from here I can just simplify. So I'll end up with -5 squared plus 1 squared I want to square both of those terms, so I have 25 plus 1, which is the square root of 26. Okay, so as of right now, both of these here are equal to each other, and those are opposite sides. So we're on the right track for this being a parallelogram. Okay, next I have to do the other two opposite sides. So I need to do side AD and side BC. So for points A and D, I have -2, 3 and -3, 0. Okay, I'm going to label those again. So I have x sub 1 and y sub 1, and x sub 2 and y sub 2. And again, I want to plug those into that distance formula. Okay, so I have the square root of -3 minus a -2, that's squared, plus y sub 2 is 0, minus y sub 1 is 3, that's also squared. Okay, next I want to simplify. Okay, so I have -3 minus a -2. So I have -1 squared plus -3 squared. Okay, square both of those terms. I'll end up with 1 plus 9. That's equal to the square root of 10. Okay, so that's one of my sides. I need to finish with side BC here. So again, looking up at my coordinates, I'm using 3, 2, and 2, -1. Okay, labeling those, I have x sub 1 and y sub 1, and x sub 2 and y sub 2. And again, we're just plugging those into that distance formula. So we have the square root of x sub 2 is 2, minus x sub 1 is 3, squared, plus y sub 2 is -1, minus y sub 1 is 2, squared. So I have the square root of -1 squared plus -3 squared. Square both of those terms, so I have 1 plus 9, which is equal to the square root of 10. And again, I want to compare these two answers that I got here. That's why I'm just leaving them in that square root form. Okay, since they're both square root of 10, those two sides would be congruent to each other. So now that I have both pairs of opposite sides congruent, okay, so since both pairs of opposite sides have the same lengths, okay, so since AB is congruent to CD and AD is congruent to BC, then ABCD would be a parallelogram. Okay, so that's using, on the front we use the slope, on the back we use distance. You want to make sure your opposite sides are congruent or have the same slope. Okay, if they do, it's a parallelogram. If they don't, then it's not. Any questions?